So this is building cloud native microservices with project Helidon session. And thanks. First of all, thank you very much for coming here. Some legal stuff from Oracle, I won't concentrate on that. So just skip this slide. A little bit about myself. My name is Dmitry Kornilov. Here is my picture. This looks the same as myself. You can basically compare, right? I'm Helidon project lead based in Prague, Oracle employee. Here is my Twitter ID. It's 0, the second one, so M0MUS. So if you decide to take a picture of myself now talking with this tag, please use that tag to basically identify me in your tweet. Right, so what I'm going to talk today about. The session is, I've done it the way that there will be less slides, more live coding. I hope you like it. So there is going to be about 10 minutes of slides basically explaining what MicroProfile is, what Helidon is, why you should use it. I will not explain why you should not use it, because the point is that you should use it. And after that, I will demonstrate quickly how to build a MicroProfile application using Helidon as implementation of MicroProfile. And this application will be a RESTful web service. We will talk about health checks. We will create a custom health check. We will talk about metrics. I'll create a custom metric, demonstrate what's the advantages of that. And during that metrics and health check exercise, we will use some basic and advanced configuration features of MicroProfile. And at the end, hope we will have time for that, I will demonstrate how Helidon's friendship with GraalVM and its advantages. And basically, we will compare a startup time of an application on JVM, and we will build a GraalVM native image and see what's the difference. So that's a plan for today. Right, and as I said, that cloud native microservice is going to be MicroProfile application, right? So who knows what MicroProfile is? Oh, very good, because sometimes, I'm talking and what MicroProfile is? Like one hand raised, not good. But here everybody knows what MicroProfile is. So I will be quick on that slide. So MicroProfile is open source community specification for enterprise Java microservices, right? And going past 3 years ago, like 2006, it started then Oracle said that it's not going to release Java EE 9, right? So it's stopping working of Java EE. So other vendors like IBM, Red Hat, Payara, Atomic Tribe, so on decided that they really want to continue creating some kind of standard APIs for cloud. Because at that time and now still there is a big demand for microservices, and Java EE kind of not the microservices stuff. So we established MicroProfile, right? And the first release of MicroProfile was actually only 3 APIs. All 3 of them were Java EE APIs: CDI, JSON processing, and JAX-RS, right? But now we have 10 releases. We've done 10 releases, and we are doing 4 releases per year. 1 major, 3 minor, which is great, right? So we're doing well. And it was 1 release, 3 APIs from Java EE. Now we have much more. Next slide, I will demonstrate how many. But before that, it's hosted on Eclipse Foundation. If you need more information, not that, this, go to microprofile.io. Take a look. We have quite a nice website. These are all the participants, by the way. And here is some information about the latest version of MicroProfile, which is 3.1. What I have information about 3.0, the previous version basically, but 3.1 has just updated version of metrics and health checks, so nothing special. So you see how many new APIs are there, right? So these 8 APIs are completely new, and it's all cloud related. So fault tolerance, metrics, JWT propagation, health checks, configuration, REST client, Open API, and Open Tracing. So I will cover in my talk today health checks, metrics, and configuration, right? Okay, so MicroProfile is de facto standard. It's not a real standard, de facto standard because it doesn't have some kind of specification process, but it's widely supported in Java community and Java vendors. So IBM has MicroProfile implementation, Red Hat has, Dmitry has, Payaro has, and Oracle has too, right? And talking about implementations, there is a special page on Eclipse Wiki, MicroProfile implementation. It's kind of official, which lists all implementations of different versions of MicroProfile and different versions of each API they have, right? So you see that the latest one is not supported by anyone. I think it's just not updated. I think some of implementations do support it. And 3.0, it was released like in August, so it's quite fresh. And only 4 implementations listed here. Helidon is one of them, right? So I'm going to talk about Helidon now. So what Helidon is: MicroProfile implementation, but in one sentence, Helidon is a set of Java libraries for developing microservices. So it's not an application server, for your understanding. It's just a set of Java libraries. So the model is Spring Boot-like. So you use these libraries to, in your application, you create a jar file. It's executable jar file. After that, you package it into your Docker container and do whatever you want with it. You can deploy it to Kubernetes. You can run it locally. You can deploy it to VM or whatever, right? So it's Docker. So why Helidon and what Helidon actually is? Helidon, and it's in Greek, means swallow, and this is how it's spelled in Greek. I know that there are some Greek people in the audience here, so they can prove that this is correct. And it's kind of a double meaning. Swallow is kind of small bird, it flies fast, so it corresponds to light, weight, and performance and these kind of things. Right, so there are quite a few Java microservices framework on the market now. Bless you. I listed some of them here on this slide and categorized them in 3 categories: full stack, MicroProfile based, this is what I'm talking about, and micro frameworks, and sorted them out by the footprint size from smaller to larger, right? So micro frameworks: Javelin, Spark, Java, Micronaut. Small footprint, functionality usually limited because the footprint is small. MicroProfile based: Open Liberty, Payara, Forntel. This is that MicroProfile implementations I was talking before, right? Footprint is usually bigger, but not so big. Functionality is MicroProfile functionality. And full stack: Spring Boot, Drop Wizard. So you know what Spring Boot is. You can basically do whatever with Spring Boot. As a disadvantage, is quite big, right? So how Helidon fits here? We cover 2 categories. We are in MicroProfile based with our Helidon MP, and with micro frameworks with Helidon SE. So I will talk about the difference between them in a bit. It's just different frameworks, right? So we have absolutely different development experience. So it's why they are in different categories. About the size, I said that Spring Boot quite big, right? So for comparison, Spring Boot application, that normal one, small one, is from 80 to 130 megs footprint size. Helidon SE application, a Quickstart I will demonstrate, is actually 5 megs. And MP, it's going to be about 21 megs, right? So difference is with SE is more than 10 times, 20 times. And Helidon MP is kind of 5 times. Right, comparison. SE versus MP. So SE micro framework, it's pure Java. So there is no magic. We call it no magic. No annotations used there, no dependency injection used there, right? So it's just a Java SE application. It's very small, and what's the main advantage is reactive and functional style APIs. MP, on the other hand, it's MicroProfile, it's bigger, and the development experience is Java EE development experience. So it's declarative style, it's dependency injection, it's familiar frameworks you used to from Java EE world. Right. So I will, in the demo, I will touch both SE and MP, right? So you will see actually the difference in the code. Let's start the demo. But before starting that, Helidon, it's open source. So it's on GitHub. And what's most important, it's Apache 2 licensed, right? It's not like closed license. It's very permissive license. So we are continuously improving it. It's very young. It's 1 year old, right? So we are working on it quite a lot. If you want to contribute, issues tracker is here. If you have any problems, submit your issue there. You see that it's quite active, right? It has a website, helidon.io. Quite nice website. Looks, there's a parallax effect here. Like, nice. Yeah. Again, if you want, SEMP things are here from my slides. And what I want to demonstrate actually the community, if you want to participate, we are open, feel free to participate. We would like to use Stack Overflow for questions, answers, solving problems. We have a public Slack channel. If you want to join, click here for direct communication with developers. Folks are quite active there. We have some FAQ. This is our GitHub, Twitter, and Medium. We have a Medium kind of, how's it called? Publication with some blog articles we're writing. Some other people too, right? But what's the most important? Probably documentation. So we have quite a big documentation sessions with guides, Java docs, blah, blah, blah. So it's ASCII doc based. So the sample can open some page. So you see that some pictures here, some code samples here, right? So on. So nice to read. Basically, on Twitter, the author of ASCII doc, don't remember his name, tweeted that, hey folks, this is kind of a nice implementation of ASCII doc. We're quite proud of it. Right. So the demo. The demo is based on one of the guides. So we have quite a few guides here. So if you want to try it, use the guides. And I will start with Quickstart MP guides. This guide basically uses an archetype to generate a project. And we actually recommend that you use this project as a template for your project you will create, because it contains all the information, all the stuff you need. It's easy to add things there. So what I will do, actually, I've done it already to save traffic and time. I used that archetype to generate a project. And this project is stored in Helidon Quickstart MP folder here. So that's the project structure. And if we open it in IDE, it looks like that. So here is a POM file. Not too many dependencies, as you see. Quite a compact POM, right? And what's good with Helidon, you can basically use any IDE with it. You don't need any kind of special plugins. So it works with IntelliJ. I kind of like IntelliJ. But yesterday, for instance, the day before, I demonstrated it on the VM, which doesn't have IntelliJ, and there is only Eclipse. I'm not really Eclipse user, but I opened it in Eclipse, and it was fine, right? So I know that my folks is using NetBeans too. So it's fine with any IDE, right? So what this application is doing? This application is a simple RESTful web service. You see that there is a called greet service. There is a greet application. Can you read it? Big enough? Yeah, I think so. And it has one resource called greet resource. And we have 3 endpoints. You see that this is kind of standard. No, not kinda. It is actually a standard JAX-RS applications configured with annotations. So 3 endpoints. One is return default greet message. It's basically our greeting, which is stored in configuration here. Meta-inf, microprofile, config properties. And it's hello. So default endpoint returns hello world. The second one is personalized greeting, what I call. It returns greeting plus your name, what you pass as a path parameter. And the third endpoint is, it's used to change your greeting. So it's hello in English now. So I will demonstrate how to change it to hello in Dutch, right? Okay. Let's just go to our command line and try to build it. I use Maven package. it will be fast to build. And as part of the build, we are running a simple test, also quick, but longer than a build, right? Okay, now let's see that I was saying that this is executable jar file. Let's just run it. Java jar, and it's in target Helidon MP jar, right? It's running now. Let me switch to another tab and test all 3 endpoints. So the first one is default one, HTTP localhost 8080 greet. Hello world. The second one is personalized. Let's greet myself. Hello Dmitry. And the third one is a put request to another endpoint. I must have it somewhere here. Yeah. So basically, it's changing. It passes the JSON message with new greeting. So I'm changing hello to hello. Supposed to be changed. Let's try it. Yeah, it works. So it's very simple. Now let's come back and see how big the jar is, right? So I will do that. So you see that the jar is only 12K, and this is not Uber jar, right? It's kind of hollow jar. We store all dependencies in the libs directory here. So let me demonstrate what dependencies are. Quite a lot of them, right? But it's not big. So if we do h target libs, you see that it's 21 meg, right? So this is what I was saying, that Helidon MP application with like a simple one, but supporting health check metrics and so on, it's 21 meg, right? Okay. You can also build a Docker image out of it. If I switch to my IDE, you see that there is a Docker file here, right? And that structure, what I showed with the libs directory and all dependencies are there, is actually very Docker friendly, because Docker is layered, and you can build your Docker image the way that you put dependencies, all the libs directory in one layer, and the application itself in another layer, because it's changing quite a lot. But dependencies are not changing usually, right? And it will make your Docker build very fast, because it doesn't need to rebuild all their images underneath, right? So there is some logic underneath it. We also provide a Kubernetes YAML, right? So you can easily deploy your application to Kubernetes. I'm not going to demonstrate it. I'm not going to demonstrate the Docker too, because it just to save time. I will jump directly to health checks, right? So do you know what health checks are? Oh, some of you, yeah. Okay. So health checks, one of their characteristics of microservices is observability. So microservice must be observable, right? And health check is a kind of part of that observability concept. And it's just a probe of your node state, simple endpoint, which returns up or down, depending on how your application behaves. And this up and down actually can be combined by different health checks. So you can have 3 health checks. If all of them are up, then the result is up. If one of them is down, then everything is down. And it's used for automatic systems like Kubernetes, for instance, to check if a node is actually healthy or not. And if it's not healthy, then that automated system, I'm saying automated because this is actually not designed for human operators. Automated system decides what to do with your node, to discard it or restart it or whatever, right? Helidon, and actually not Helidon, it's by the MicroProfile spec that each application, MicroProfile application, must support health checks. And health checks is a MicroProfile specification. So all vendors implementing MicroProfile APIs must support health checks. We are supporting health checks too, and let's see how. Let's just run it again. Yep. So the health check is on the endpoint called health. If I run it, it returns this kind of JSON file, right? And you see that the outcome is up, and there are 3 checks. One check is a deadlock check, it's okay. And another one is disk space check, it's also up, and it actually returns some additional data, like how many free spaces on the disk. I don't have much really, but it's still up. And the third one is heap memory health check, right? This is what's provided by Helidon by default out of the box. But you can create your own health check. For instance, if you want to check the database, is database connection alive? Or if you want to check if other application which you depend on is alive or not. You can add your own health check, and it will return a status up or down, and depending on that, automated system will restart or not restart your node. And then what I'm going to do now, I'm still messing out with that. Okay, I'm going to add a custom health check. Forgot to say that this health endpoint, it belongs to the older health check 1.0 spec, and the newer 2.0 supports 2 more endpoints, and these endpoints are liveness, which returns basically the same stuff, and readiness. Ready. It's kind of empty at the moment, and we are going to add a readiness check. The difference is that readiness is is your application ready or not, and liveness is the same as before. Does it run properly or not? Right? Okay. To add the health check is very simple. You just need to add another class. Let's call it state health check. And this class must implement health check interface. Health check. This one, right? And we actually need to implement some methods. And you need to implement only one method called call, right? We will add, this is going to be application scoped bean, application scoped. And to indicate that it's readiness health check, we need to annotate it with readiness. That's it. Now we need to return up and down, and for simplicity, the first version of health check, I will make it that it will return down all the time. Yeah, it's kind of weird, but we will change it later. Health check response. And I'm going to name it, so it's not going to be unnamed health check. It's going to name it state. And you see that it has methods up and down, so you can return up and down, right? And there is another method called state, where actually you pass a Boolean variable there, and if it's true, then it returns up. If it's false, then it returns down, right? I will just do that for simplicity and build it. Looks fine. Let's just build it and see will it work or not. Here. I'm not using usually IntelliJ stuff to build your application because sometimes it doesn't build it right, you know, and I'm going to skip tests. And if it won't build it right, I'll get nervous and so on. So let's just use the standard Maven stuff, right? And actually, I was saying that I used Eclipse to present a couple of years ago, and Eclipse doesn't automatically save your files, which is quite bad. So I was coding, everything is fine. I built an application, it doesn't build. No, actually, it built, it didn't run. Oh, what's happened? And someone from my audience said, you forgot to save. Come on, I never saved it. Anyway, yeah, it's done. Now let's test it. It was a readiness health check. Oh, the same thing happened again. I forgot to run it. Let's just go back, run it. Yep. Right. So you see that it's outcome down, and in the additional information, we have a name that our health check called state, and its state is down. So if you have more than one, you will have all of them listed here, and you will find out which one is down, right? So let's just go a little bit further. It's not good to have this kind of health check, right? So let's just improve it a little bit. And let's make the state up or down based on the configuration variable. So if configuration variable is up, then we are up. And if it's down, then it's down, right? So first thing I'm going to do, I'm going to use MicroProfile configuration API for that, right? And I'm going to add a property in our configuration file. By the way, that MicroProfile config properties file, this is not what we imagined, right? This is actually according to the MicroProfile config standard, the standard configuration file for your MicroProfile application. And by default, MicroProfile application reads configuration from this file. And if you open main here, it actually says when we start server will automatically pick up configuration from this file, right? Okay. Right. I will do application state, and the status, the value is going to be down, right? Now we need to somehow read this configuration property in our health check. But it's also very easy. We'll just inject it there using CDI. So I create a private property, string property, called state. And I will use CDI inject. And there is a special annotation for configuration called config property. There you actually specify a name of configuration property to inject the value from. And the name is up state, right? Now we need to modify our health check. And as I was saying, that there is a method called state, right? Which you pass Boolean there, and up and down depends on true or false of a Boolean. So up equals ignore case state. Something like that. Let's just try it. Let's keep forgetting the right or left, you know. Build. There was another problem with Eclipse a couple of days ago with that. When I was typing stuff there, or at least I don't know how to use auto-completion there, auto imports and this kind of stuff. So I had to add imports manually, which is quite terrible. Right, we have it. I understand that it's because of my stupidity and because I don't know how to use Eclipse anyway. All right. Right, we have it down. So now it reads from the configuration variable, it returns down again. Next sample, MicroProfile configuration. It's not only reads configuration from that MicroProfile config file, but it also supports configuration layering. Possibly you know what is that, but I'll explain in a couple of words. So you can have multiple configuration sources, right? And each configuration source have its own priority, right? And the higher priority sources overwrite values from the low priority sources. So if you have one variable defined in the low source and a higher source, the same variable, then higher source will override the value. And by default, it supports sources from system properties and environment variables. It's there already embedded, right? So what I'm going to do now, when I start my application, I actually pass there a system property. And this time it's going to be up. And technically, this configuration source has a higher priority than configuration file, and it should overwrite out down to up, right? So D up state, and it's going to be up, right? Let's see. Right. Click. Up. Right. So what's happened that I passed it as a system property, it's also defined in the configuration file. This one is high priority, so it overwrites that down to up. Right? Okay. But again, you need to pass it when you start your application, right? Which is also kind of not good. Let's just modify the source the way that your application will get notified then configuration properties changed and change the health check status automatically. Right? In order to do that, we should actually use custom configuration because that functionality doesn't fit into their default functionality. So we won't use default configuration, so I will just remove in this comment. And instead, I'm going to build configuration from scratch. So it's stored in the config class, right? This one, config. And as everything here, there is a builder to build configuration. And I'm going to add a couple of, sorry, it's kind of weird. I didn't want to do that. Don't do this, right? And sources. I was going to add some sources. And first source is going to be a file source. And this file, I didn't create it yet, so I will create it now. It will be outside of my application in the conf directory, not conf. And it's going to be named mp-yaml. It's going to be YAML application source. Let's just do auto import. And this file is going to use polling strategy. Polling strategy is actually what I was saying. It means that your application will get notified if something's changed there. And the polling strategy I'm going to use is watch, right? That's one. And I will make this source optional. Optional, it just means that if it doesn't exist, your application won't throw exception. If it's not optional, then it will. So if you configure it as not optional and it's not there, application will not start, right? Okay, it's still red. Oh, sorry. Why it's red? Oh yeah, it's fine. Build it again. Right? Build it later. But before that, I will add another configuration source. So one is file, and another one, we still want to read configuration from our MicroProfile config properties, right? So we are building it manually, so we need to add it there. And in this case, it's going to be class path. So basically, take configuration from class path. Lame coding style, sorry. Import static method, and it's going to be this. And class path is meta inf microprofile config dot properties, something like that, right? Sources is there. Now I need to build. So I'm not red anymore. So see, two configuration sources. One is file, another is ours. And file has a priority, right? I'll just remove it from here in case we don't have it duplicated. Going back here. Right, okay, config is there. Now we need to pass it to our server. So instead of create, I'm going to use builder, and I'm going to use config. I pass here config, and I will build and start. Something like this. Sounds good to me. Now let's change a little bit our health check, because in this case, it's not going to be string class. It's going to be supplier. Supplier of strings. And yeah, here should be get. Sounds good. We can build it now, but before doing that, let's just create that file, right? So let me just go there. Sorry, it's not here. I will better do it here. Make dir conf, and inside that I'm going to create conf mp YAML, right? And in that mp YAML, I'm going to add up, and I'm going to add state, and state is going to be down, right? Something like that. I'm going to save it. Go back, Helidon MP, build it, and run it. Do you understand what I'm doing? Good. And this is the most difficult part because it's easy to make mistakes here. So let's see, did I make a mistake? Did I make a mistake this time or not? I don't need that property here. Yeah, this is runs. Now let's check. Down. Good. Now, I think it's here. Yeah, and that's jfall. Yeah, and let's just use vim conf. Application is still running, by the way, right? So I'm going here, and I'm going to change it to up, right? On Mac OS, it could take a little bit of time before that polling actually will work. So let's see, but it's up, right? So again, what did I do? Application is still running, and there is a configuration file. It was down before. Health check will return down. After that, I went to Vim and changed it to up, and without restarting application, changed to up. So this is a demonstration of the polling strategy, right? Now, quickly about metrics will be quick, and after that, we'll jump to GraalVM stuff, right? Okay. Yeah. Sure. This is what I would demonstrate it then. No. I demonstrated it then. Actually, I was doing passing it to Java. Here. Look. I'm not sure that you can define a file name and pass it to configuration using environment variable or system property. I'm not sure about that. I need to check with folks if it's possible or do. Just ping me after the session, right? I'll ask folks, and maybe it's possible. I don't know. Right? I'm just a manager, you know. Right. Okay. So, is application running? Metrics. What is metrics? Metrics is if health check is about node state up or down, metrics is about telemetry, right? So you can meter some things collected in Prometheus and visualize it in Grafana, right? I'm not going to demonstrate visualization stuff. And what you can meter is actually, for instance, how many times your endpoint was called, or the average time how long it took to execute a method, whereas some other stuff which you can meter, right? And it's on by default again, and the endpoint is, try to guess, metrics, right? And then I do that, it returns this funny stuff, and it's actually the Prometheus format of metrics. And if you want to return it in JSON, you need to say that it accepts JSON, right? And I'm going to use not application metric, but just general metrics, right? So this is what we have. And you see that there are two matrices, base and vendor. And a base is what, according to the spec, MicroProfile has metric spec, of course, what each vendor implementing MicroProfile metric should return in base. So basically, if you go to one implementation to another, this is going to be the same. Vendor, it's what vendor decides to put there. And we, as Helidon, decided to put there some things here, like number of requests, like GPRS stuff, and some other stuff, right? And it's also possible to create your own metrics. which I'm going to quickly demonstrate. But before doing that, if you don't know what these numbers are, just do options. And options returns metadata, right, about your metrics. You see that there are quite a lot of descriptions, so you can read it and just understand what this metrics is. Right? Now, let's measure how many times our default message was called. So it's as easy as add counted annotation, right? There are some parameters. I'm running out of time, so I won't demonstrate that. And let's use timed metrics for our personalized greeting, right? And you will see the difference. Recompiling, stopping. Yeah, running. Done. And the testing. So metrics, you see, oh, so it's options. Come on. Yeah. So base vendor, and here is application metrics, right? So you see that it's 0, right? And 0 because I didn't do any requests. So let's just do some requests, like our standard greet. I do just quite a few of them, so it's not 0, it's not 1, some number, right? And personalized. Yeah. And now if you do metrics, you see that I actually pressed the button 8 times. And these numbers are some kind of times of execution personalized greeting. If you use Prometheus, if you use Grafana, you can have a nice graph for that, for these two, right? Okay, the third part of observability is tracing. I'm not going to demonstrate that, but it's also supported by default. That all microprofile applications are traceable by default if you use Zipkin or Jaeger. Just a little bit of configuration, adding another dependency, and you will just have it out of the box, right? Okay, 7 minutes. Helidon SE, right? Another part of Helidon. It's just a set of libraries. Configuration, security, reactive web server, not the same configuration as microprofile, slightly different, right? And web server supports health checks metrics tracing by default. Again, with slightly different Helidon SE-based APIs, right? Helidon SE is fast, so according to some public data, here is a source. Startup time of Helidon SE application on different JVMs listed here, so we're quite quick and start. And according to Tech Empower, JSON request per number, we are collecting the data benchmarks for different frameworks. We're actually doing quite well too. Micronaut is a little bit faster. We are working on it. But what's important, we are faster than Dropvisit, we are faster than Spring, right? Again, this is not what I made. This is a public data sources here. You can get my slides and see this data, right? GraalVM. GraalVM, we are using native image feature of GraalVM, but you can run Helidon application in just GraalVM for polyglot features. Native image allows you to make native executable of your application. It's supported by SE only at the moment, and P will come later, next year. And basically, you will have an executable. I will build macOS executable, and the advantage is fast startup time and a small executable size, right? So I will demonstrate it in a bit. Again, I'm using a sample from a Quickstart, and this is Quickstart SE in this case, so I'm generating project using that. And I've done it already, and it is here. So a project looks like this. Again, this is a Maven application. Again, Docker is there. Again, Kubernetes is there. And to show you no magic stuff, see that main method has a main main class has a main method, and you need to manually start with server. You need to manually start login. You need to create configuration, pass it to your server. You need to manually add metrics, health checks, and other supports. So the style of developing similar to Express.js, which we inspired to, and I've seen some tweets that's similar to Go. Can't prove it. I'm not a Go programmer, right? So a resource looks like this. So you need to basically add your routing. There is a path and some handler for this routing. And I have handlers for our free endpoints. It's the same application as greeting application I was demonstrating for MP, right? Now let's build it and check the sizes, right? So I'm going to Helidon SE Quickstart this time, and I'm going to do Maven package. Didn't build it before, so hopefully it builds. Right? So testing, address already in use. You know why? Possibly you do, right? Because of that. So, but it's built, right? So, sorry, I just demonstrate the size. Didn't build. Wrong tab. The MP server was running there on the same endpoint. Yep, now we have it. And you see the size, 11K. Again, dependencies are in leaps. And the size in leaps, target leaps. If about 6 megabytes. I was saying 5 megabytes, but it's 6 megabytes. So application in the SE with a similar functionality as MP I demonstrated is 6 megs. MP is 21 megs, right? So 2 and something times difference, right? Now let's do GraalVM build. But before I do that, we are going to test the startup time, right? So I will add a small modification to my application that it actually stops right after server is started, right? So when accepts, I put here system exit 0, right? So when all initialization is done, it just stops, and I'm going to use Unix time utility to measure that, right? So let's rebuild it and see how fast. I'm going to use skip tests. How fast it starts on JVM. Okay. Where is it? Okay, sorry. I'll just do it manually. Time, Java, jar, target, Helidon, SE. You see that 1.79 seconds, not too bad, right? 1.80. On my environment, it's usually from 1.5 and 2 seconds. Now, let's do a GraalVM build. We have a special profile for that. And in order to do that, you just need to use it. So package skip tests and p native image. GraalVM, okay, yeah. To configure GraalVM build, we need to configure a GraalVM home variable. So I'm going to create it now, which points to your GraalVM installation, right? And my GraalVM installation is in my home GraalVM 1. What else I have? The latest one. And you need to do on the Mac context home. If you're on Linux, you don't need to do context home, right? So now, if it builds, let's just make sure that it builds. Yeah, it builds. So it will build about 2 minutes, just enough. Not enough. 2 minutes, okay. While it's building, GraalVM advantages and disadvantages, right? So it's a trade-off. So if you really need your application fast startup time, GraalVM is your choice. If you need a smaller image size, your executable size will be smaller than JVM plus your application. But it will, when your application grow bigger, this advantage will be smaller and smaller, right? But anyway, if you need it, GraalVM is for you. But if you need performance, GraalVM doesn't know anything about your runtime, so it can use only static optimization. JVM hotspot actually knows about your runtime, and it can optimize your application while it's running. So if you are using a long-running application, maybe JVM is a better choice for you. If you are not using long-running application, you use functions or something like that, then GraalVM is a great choice, right? Also, GraalVM adds some development restrictions. So if you use some kind of runtime code modifications, or if you use reflection, or if you use proxying, then reflection and proxying you need to configure. You need to tell GraalVM where actually you use it, so your native image properly built. If you use some code modifications like ISM or whatever, then it will be even more complicated, right? So maybe it's not really big deal, but these restrictions are in place. Right, so I finished talking, but it's still building. So it usually takes 2 minutes. It's almost finished. But for bigger applications, it's another disadvantage, by the way. For instance, well, right, let's just run it. Target, Helidon SE, startup time. Time, target, Helidon SE, startup time. Look, 001, 001. Sometimes it shows 0, so it starts immediately. And the last thing, image size, ls, lh target, right? So this is the executable, and it's 19 meg, right? Jar file itself is 11K, right? So 19 megs is bigger than libs plus your jar. It's 6 megs, but it's definitely smaller than if you add JVM there, right? So that's the size of our native executable. Right? 2 minutes out of time, but we've done. Thank you very much. If you have any questions, just come to me after the session.